project is called Flyover Mapping and Modeling. It's an undergraduate research project supported by a NASA grant as well as 2 CMU Surge grants. The goal of our project is to develop and demonstrate the technology to create high-resolution 3D maps of lunar surface during a lunar landing. So this whole project fits into the context of the Carnegie Mellon and Astrobotic Google Lunar X Prize mission. And the goal is that the technology that we develop here will be eventually used during that mission so that as the lunar lander descends to the moon's surface, it can fly over moon craters and what's known as skylights, which are entrances to caves on the moon. And using cameras and a laser, this sensor package and the software that we write will be able to collect measurements of the lunar surface and stitch them together to create these high-resolution 3D maps. And those will be used for both scientific research of sort of properties of the surface, as well as navigational needs, such as planning a safe path for a moon rover to traverse as it's on the surface. Lunar skylights are entrances to caves on the moon, and they kind of resemble craters, but because they're these collapsed pits, they're pretty hard to detect, and they were only recently discovered on the moon. So they haven't really been fully studied yet or characterized on the moon, but they exist on Earth, so scientists are pretty familiar with what they look like. So the purpose of this project is to collect a really good understanding and set of data of a lunar skylight during the next lunar mission. So using a motor, we're able to sort of actuate the laser range scanner and a high-resolution color camera on our sensor package. And what that'll allow us to do is, as we fly over the lunar pit, we'll be able to continuously point our sensors towards that pit on the ground. And that'll give us a really great extended coverage of that target, more so than just having a camera on the lunar lander and doing post-analysis.
We designed and fabricated the sensor package for us to collect and analyze the data to make a rich 3D model of a lunar skylight. On the outside here, we have a stereo pair black and white camera. On the inside, we have a LiDAR laser range scanner and a color camera on a rotating gimbal, and this allows us to track our target to get more data from it. On the left side, we have not currently attached the thermal camera, which will be used in the context of looking for ice on the lunar surface. And on the right side here, we have the motor, as well as a kVH inertial measurement unit. And this is really crucial so that we can get really precise relative motion of the package to generate good data. On the back, we have all the computing payload, which allows us to, in real time, analyze and compute all of the data we have collected.
As we discussed, the purpose of the sensor is to build a high-resolution model of a feature on the ground while flying over it. On Earth, you would typically do this with a high-resolution GPS receiver and use that to process the data from the laser and color camera. Unfortunately, on the moon, we don't have access to GPS technology, so we have to come up with another solution to this problem. To do that, we're using a technique called structure from motion. That allows us to integrate our stereo camera observations with the IMU and generate a very precise idea of where we're at each point in time. And then we can use that knowledge to combine the laser and camera data into a very high resolution and accurate 3D model.